Today I am having coffee with James Renwick, a climate scientist from Victoria University of Wellington.
So I study the atmosphere, why the winds blow, where they blow, what's changing about the way the temperature and rainfall and wind patterns in the atmosphere are playing out. I thought I'd talk a little bit about what's known as the Southern Annular Mode, or more colloquially, the SAM, S-A-M. It's a really interesting and quite curious feature of the climate of the Southern Hemisphere. So the Antarctic here is very cold, and the tropics up here are very warm. So there's a big difference in temperature between the tropics and the pole, and that's what drives the strength of the winds. So in the Southern Hemisphere we have these really strong winds, westerly winds that blow all the way around the Southern Hemisphere. And what the Southern Annular Mode is about is just, whereabouts are these winds and how strong are they, because it does vary from month to month. What happens is this big ring of air that's blowing around at 50 kilometres an hour or so, it gradually sort of pulses in and out. So we get really good weather when the westerlies contract towards Antarctica. That's what's known as the positive Southern Annular Mode. But then the opposite can happen, and sometimes the westerlies actually expand away from Antarctica, and then it can start to blow pretty strongly south of Australia, and the westerlies can get really strong over New Zealand and the southern part of South America. And in that case, you can forget about the sunshine. The weather can get really stormy and unsettled and windy over New Zealand, and this is what we call the negative phase of the Southern Annular Mode. So this thing, it jumps around from positive to negative every few weeks. There's no particular timescale. The downside, the catch is that these changes between the positive and the negative happen basically at random. So we can't predict more than a few days in advance what's happening here. Funnily enough though, there's a longer term feature to the SAM that we are able to understand and predict. A lot more of the months in the last 20 years have been positive SAM rather than negative SAM. And the reason for that is that in the Southern Hemisphere in the last few decades, this difference in temperature between the warm tropics and the cold pole has actually increased. Because with greenhouse gas increase, climate change, the tropical region's getting warmer, like the whole world is, but actually the South Pole, Antarctica, hasn't hardly warmed up at all. Part of the reason for that is something a bit unrelated really, the ozone hole. So in the spring and summer, the ozone over Antarctica mostly disappears. You take the ozone away and that cools the atmosphere, so you make the air, at least over Antarctica, even colder than it would be normally. So that increases this north-south temperature difference. What happens in the future is kind of tricky to work out, because the ozone hole is starting to recover, and that would help to warm up the atmosphere over Antarctica, so reduce that difference in temperature. But greenhouse gas increase still happening, so the tropics are still warming up faster than the Southern Ocean and the South Pole. It's going to be a bit of a wait and see. It depends very much how quickly the world reduces its emissions of greenhouse gases. So knowing more about the SAM, both its past and its future, will really help us to plan for the future of the climate and the future of how we're going to operate as a society in a country like New Zealand, or indeed in Australia or any of the other countries in the Southern Hemisphere.